Welcome to Math 1314. This is section 1.6. In the first part here, we're looking at solving some equations, and these equations, like the one here in question 1, has variables in the denominator. It looks ugly and it looks complicated. So step 1, I want to factor all of the denominators because I want to know what answers could make our problem undefined. And when was undefined? Undefined was if the denominator calculated to be 0. Well, let's see, z plus 1, I can't do anything with that. Z plus 5, we're stuck with that. What about this big giant one here? Let's see, z squared plus 6z plus 5. Let's see if I can factor that as a product of two things. Let's see, z times z is the z squared. 5 times 1 is 5. If I add together the middle and the outside, I have a 5z, a 1z. That does give me the 6z. So that tells me how the denominator on the right factors. Next, I'm looking at this thing about bad answers. What would make my problem undefined? So I don't want z plus 1 to be 0, so z cannot be minus 1. I don't want z plus 5 to be equal to 0, so that says I don't want z to be minus 5. So I just want to keep track. Maybe we won't get any of these answers, but if we do, we would need to throw it away. Next, I want to get rid of all these ugly denominators. So I'm going to multiply through by this product because that would cancel all denominators. So you can see here, I multiplied every term that we had by z plus 5, z plus 1. In the first part, the z plus 1 cancels, leaving me the 3z and the z plus 5. In this piece, the z plus 5 cancels, giving me a 3 and a z plus 1. On the right, everything cancels, and so I just get the top part. Next, I need to distribute. 3z times z is a 3z squared. 3z times 5 is 15z. I get a minus 3z, and I get a minus 3. So now it's a question of collecting up some terms that go together. Let's see, 15z minus 3z, that's this 12z. All right, nothing else combines. I'm going to bring everything on the right to the left. 3z squared minus 2z squared. That's a 1z squared. 12z minus 14z, a minus 2z. So our whole problem has boiled down to this one item, which does factor. Let's see, z times z, z squared. A minus 3 times 1 is a minus 3. And if you look at the inside, a minus 3z, a 1z, and that does give me the minus 2z. So let's see, z minus 3 is 0, so that gives me z is 3. Z plus 1 is 0, I get z is minus 1. So we're happy, we've solved the problem. But now I need to ask myself, are any of these answers that would make my problem undefined? Let's go back and look. The bad answers were minus 1 and minus 5. We got minus 1 as an answer, so I need to throw that one away. And this is our one answer, which is z equals 3. All right, question 2 is a little bit shorter here. I look at all my denominators. The only answer that would be bad is if p were equal to 0. So now I want to multiply by something that's going to make everything cancel in the denominator. And so I'm multiplying through by p squared. Every term by p squared. So I get a 7p squared. Here, one of the p's cancels, giving me a 6p. On the right, p squared cancels, giving me the 1. So next, I'm going to bring the 1 over to the left, so making it a minus 1. And so now we're wondering how to make this thing factor. Well, let's see. 7p times p, that's a 7p squared, minus 1 times a plus 1, that is a minus 1, so that part is good. What about the inside and outside? Well, let's see. From this piece, I get a minus p. From this piece, I get a 7p. So 7 minus 1 is the middle term, which is 6. So let's see. I'm going to solve the first part, move the 1, divide by 7. And here I move the plus 1, making it a minus 1. And so we get two answers. Now both of these are good because the only bad answer was p equals 0. So in this case we get two solutions. All right, question 3. All right, so first off I need to see if anything needs to be factored. Well, this first piece only has two terms, and that's a good sign that maybe something's in common. And what's in common here is a d. So take the d out. D times d, d squared. D times minus 4 is the minus 4d. Now looking at this, what could be bad? Well, let's see. I don't want this term to be 0. And I don't want d minus 4 to be 0. So the things that are bad would be 0 and 4. Alright, so I'm going to multiply through by d minus 4 because that'll make all denominators cancel. Alright, so in the first part, let's see. Everything cancels, giving me a 32. Second piece, nothing cancels, so I get a 2d minus 4. And on the right, the d minus 4 cancels, giving me an 8d. Alright, so far so good. I need to distribute this. 2d times d, 2d squared. 2d times a minus 4 is a minus 8d. Alright, so let's see. Anything combined? Well, the order is a little strange, so 2d squared, that's in the front. I've got a minus 8d. I'm going to bring the other one from the right to the left. Minus 8, minus 16, and this 32. Now I can reduce the numbers because 2 will go into everything, leading me to this particular part, which does factor into d minus 4, d minus 4. Let's make sure. D times d, d squared, minus 4 times minus 4 is a plus 16. The inside, the middle, and the outside does add to give me a minus 8. And so, I set each part equal to 0. Well, they're the same, so I only need to solve one of them. And I get that d is 4. And we're happy. Again, we solved the problem. But no, we found that our only possible answer is d is 4. And we said d cannot be 4. Therefore, we throw it away, and this problem has no solution. There's no number that you could ever plug in to make that a true statement. All right, the second part of section 1.6. they're giving us a product of things equal to 0. Well, whenever there's a product equal to 0, I can grab each piece, set it equal to 0, and solve. So from the first part, minus 7x is 0. Divide everything by minus 7. If you remember, 0 over something not 0 is just 0. 2x minus 5 is 0. All right, I move the 5 and divide by 2. And the last piece, the 5x plus 2, move the 2. So move the 2. Here we moved the 5. And so I get 5x is minus 2, and then divide everything by 5. And so we get 3 answers here: a 0, a 5 halves, and a minus 2 fifths. Not too bad. All right, in question 2, we have the same situation. A product of things is equal to 0. Now, I do have a product, and you see this thing in the front here, there's a minus 5. Well, there's no variable in it, so I'm not going to set that to 0 because it can never be 0. It's a minus 5. This piece could be 0, so t squared plus 5 is 0. T squared minus 11 could be 0. Now, in both of these are perfectly set up for the square root property. I move the 5 and I move the minus 11. T squared is minus 5, so something squared equals a number. In both cases, t squared here is 11. And so by the square root property, I get t equals plus or minus the square root of the right-hand side. All right, on the right here, I get plus or minus square root of 11. Nothing else I can do with that because I can't simplify the square root of 11. Here, because it's the square root of a negative number, I pull the minus 1 out as an I. So, in this case, we get 4 solutions. I square root 5 minus I square root 5 square root of 11 and minus square root of 11. All right, in question 3. Question 3, we have 4 terms. Whenever you have 4 terms like that and nothing combines, then there's a good chance we want to solve this by grouping. And I want to group it together in pairs of 2. So I've got the first 2 here, and a second 2 there. Now, when I group together the first 2 and I put in some parentheses, you can always do that, and that will not change anything. But when I group together the last 2, I need to be concerned with what's connecting the first 2 and the second 2. And what's connecting here is this minus. So when I pair this up, if I just left it paired, I would have changed the problem. Why is that? Well, you see, pairing it up, I get a minus 8a, and I did have that. But I need minus something to give me this minus 4 back. That means I've got to change the sign of the second item. And again, I'm only having to do this because the thing connecting the first 2 is a minus. If it were a plus, then I can just connect them and there's no problem. But because there's a minus, I have to adjust the second sign. After that, I'm taking out what's in common. What's in common is a 9a squared, leaving me 2a plus 1. And in the second part, I'm taking a 4 out of that, leaving me a 2a plus 1. Now that part here in red is in common, so I'm going to take it out in the front. And what would be left is 9a squared minus 4 is 0. Alright, so I've got two pieces here. Grab the first piece, set it equal to 0. I get 2a is minus 1, and I divide everything by 2. Now for this piece, the 9a squared minus 4 is 0. You've got two options. One, you could factor it. 3a minus 2, 3a plus 2, and then solve each piece. Or we could use the square root property, move the 4, divide everything by 9, and now I have something squared is equal to a number. And so a equals plus or minus the square root of 4/9. Well, square root of 4 is 2, square root of 9 is 3, and so in this case we get 3 solutions. Minus a half, 2/3, and a minus 2/3. And in our last problem for section 1.6, we have some big numbers. We have a large exponent, and panic sets in. Well, the first thing I'm wondering is, can I reduce these numbers? Will 3 go into 243? And the answer is yes. It goes in there 81 times. So I divide everything through by 3. That gets rid of the thing in the front. And so we're now down to this. Now the question is that factorable? Let's see. I need two things to multiply to give me m to the fourth. All right, well, m squared, that'll work. I need two things that'll multiply to give me 81. Okay, well, that's a 9 and a minus 9. And if I add together the middle and the outside, notice they do cancel, and I have no middle term. So we're in good shape. And so now, set each part equal to 0. First part, I'm going to solve by the square root property. Move the 9. Something squared is equal to a number. And so m is plus or minus the square root of 9, which is 3. In the second part, I'm moving the 9, so m squared is minus 9. So m is plus or minus the square root of minus 9. Remember, I need to split off the minus, and that's the I. Square root of 9 is 3. And so we get 4 solutions, which is not surprising because we had m to the fourth power. And so we get 3 minus 3, 3i, and minus 3i. And that concludes section 1.6.